I've actually known Gilad for 30 years now and was excited to see some of the early Twitter clustering work that even today you wouldn't actually see in most companies. We'll explore what embeddings really mean, why is this important for entrepreneurs and not just a kind of a byproduct or something that people don't need to know, and why you don't actually need to build a foundation model to be an AI company, but you also don't do a GPT wrapper and call yourself this new AI type company. Welcome to the first episode of Almost Human, a podcast that explores today's AI world. What's hype, what's transformative, and how it reshapes life for investors, startups, and Israel tech. This podcast is not just for deeply technical engineers, but also for entrepreneurs or professionals in the space eager to cut through the noise. I'm almost excited. AI has its buzzwords, but every once in a while, you hit a concept that quietly underpins everything, and suddenly you can't stop seeing what you can do with it. For me lately, that's embeddings. Most people, even seasoned engineers, still think of them as a way to make text lookup work in a RAG system. But embeddings are way bigger than that. They're how you can cluster content and people by taste, by behavior, by patterns you didn't even know were there. That shift unlocks entirely new ways to build products. Think about what happens if, instead of selling keywords like Google AdWords, you start selling user embeddings. Entire industries, from ad tech to affiliate marketing, gets rewritten. And there's a deeper layer. Once you operate at the embeddings level, you realize alignment itself changes. Feed an LLM tokens, it plays by the rules. Feed it embeddings, and suddenly you're closer to machine code. The spirit of the law doesn't apply the same way. That's both exciting and unsettling. To explore all this, I'm joined by Gilad Lotan, head of AI, data science, and analytics at BuzzFeed. His work sits at the intersection of data, culture, and creativity, understanding why people click, share, and connect. Together, we'll explore what embeddings really mean, why they're the hidden layer behind so much of AI's power, and what opportunities this creates for entrepreneurs. I'm Eden Shochat, equal partner at Aleph. Welcome to Almost Human. Let's cut through the noise. So, Gilad, welcome.
Thank you, Eden. It's great to be here, and it's always so nice to see you.
Let's jump right in. So most people think about prompts and chatbots when they think about AI, but embedding is kind of this infrastructure layer. Some, including you, would probably call it unsexy, right? But it's the cornerstone of anything and everything about LLM. Can you cover this quickly?
Yeah, absolutely. Absolutely right. LLMs are the least kind of sexy of the AI topics, and it's the most important thing that nobody talks about or is sort of severely underhyped. So I'm glad we're having this conversation, and I've seen it have the development and capabilities of embeddings over the past few years have really opened up like immense opportunities for us as a content company. But honestly, any service that has to deal with content, which includes many of the kind of tech companies that we know and love, I think one of the core problems historically with data science, and I've worked in the field for many years, you're always trying to understand what the content is about, and you're very limited by tags, by named entities. We used to use like TF-IDF, where we try to count the words and normalize and see sort of the frequency of appearance of words in this corpus versus other corpus. So there are all these NLP tricks that we learned that were very useful, but were super limiting in really understanding what a piece of text or what a string is about. And over the past 10 years, there have been all these like really incredible advances in our ability to extract semantic meaning from a string. And so now, rather than saying this text is in this category, we're classifying and saying this is about celebrity, this is about sports, this is about news. You can get in a really sort of nuanced understanding and say the appearance of these words together make it so that I can match, this string with a different string that has very different words, but captures the same semantic meaning. So I'd say that capability is really unlocked by embeddings, and the ability to say, this text is similar to this text, but not because they have the same words, but because they have similar meanings. And so that's a huge, huge, huge difference and huge unlock. And for product, there are I think so many opportunities that we found.
One of the early examples of embeddings was king minus men, right? Plus woman equal queen. Like, how do you explain that? Like, people don't realize of how meaning turns into math, which is effectively what embedding is all about, right? So why does the sentence math works?
Yeah, so the interesting thing about embeddings is that they're effectively a layer from a neural network that has been trained on, let's say, a corpus of text, right? If we're talking about text embeddings. So you train this neural network that has all these layers, and what you're doing is effectively extracting one of the layers, usually close to the output. So you're still operating in high dimensional space, right? And you're effectively turning a string or words into a vector. And so what you commonly do with embeddings is you say, okay, here's a string, let's embed it. That means turn it to a vector. And here's another string, let's embed it, and then let's calculate how similar they are. And so you're effectively operating in vector math, and you're calculating cosine similarity. You can subtract, add vectors. And it's sort of, because the neural network is trained on semantic meaning, you can effectively operate with math on words, which I think is very intuitive for anyone who uses the tools, but may not be quite as intuitive for folks who are not in the space. But it makes this really useful because it makes basically the action of trying to find something similar, it's a simple math operation, or the act of trying to find a group of items that are similar to each other, again, pretty simple math operation.
Which is interesting because it's not just, it's a distance, right? So you can search for something as similar, but you can actually say, hey, I'm looking for a piece of content that is similar to this, but is as dissimilar to this as possible, right? Because that's also a distance operation, right? And so you can actually cut and choose between different, it's like, and I think we'll speak about this later, is content filtering of the past, right?
Yeah, so I can give us a specific example that may help understand this. So, with BuzzFeed, we write a lot of content, and we've used embeddings in many, many ways. But one way,
so not everyone is familiar. Like, how huge is BuzzFeed? Like, just give some numbers of articles, not of like, because the embeddings that are really cheap, unlike LLMs, are expensive. So at your scale, there's no way really to analyze every piece with an LLM.
Oh yeah, I mean, we have hundreds of millions of pieces of content. We have video, we have text, we have long form, short form, we have news under HuffPost, we have lifestyle brands, like one of them is called Tasty. It has some of the largest social media pages, like the biggest Facebook page and TikTok pages. And then BuzzFeed is an entertainment and lifestyle website. Hundreds of millions of users. So one of the largest digital publishers. And a lot of our data, obviously there's the content that we create, but also the signals around the content. So who's consuming, how often they come back, what actions are they taking on the site, etc. And so we use, we've sort of integrated embeddings into our kind of metadata suite and kind of feature store. So every time we publish a new article, there's a job that runs, creates an embedding, integrates it into their recommender systems, right? So the new article can be considered to be displayed near other articles, or to certain users that display preferences. And then so that's sort of one very standard approach to why embeddings are very useful for us as a content company that wants to show users content. But there are also a handful of internal tools that help our writers be a lot more efficient. And so we write a lot of shopping content, and we work very closely with Amazon, Etsy, and other kind of e-commerce shops. And one of the things that our teams have always struggled with is they're always putting lists together, lists of items to promote, right? And we have these databases of different products that we've promoted in the past. We have all these metrics around them. But it's always been very hard to query this database because we needed great tags in place. And many of the articles on BuzzFeed are not necessarily your typical kind of standard categories. So there could be a writer that wants to create a list of shopping items for, young couples who just moved to New York City. We want like a list. Here are the 10 things you need to get. And what embeddings do so well is they can capture, because they have the semantic understanding of text, they can identify the items that are most relevant and most similar to this string, furniture, young couples, New York City. And that, even just that capability itself has saved us many countless hours for a team and has made the team a lot more efficient.
That's an awesome point, like internal tooling. And I think implementing AI in many companies, people are afraid initially of just showing that to the user. But building internal tools and just making things more efficient is a really interesting topic. But you actually make a point of how should we relook at how a user is defined, right? Because a user, especially in media sites, is defined by what's interesting for that user. So I assume that now, if you think of BuzzFeed, you'd say, hey, we're a marketplace that there's some attention that a user is willing to give, and we need to show that user the most appropriate piece of content in the most minimal amount of time. And that happens. It's almost an ongoing process, and it's also educating the system of what was of interest for future for future viewings. How is that stack built? Like, how do you very quickly find what's of interest for a specific user when they come in?
Yeah, great point. So I think it depends. So there are many pieces to this system, but you're effectively talking about a recommender system, right? And how do we build a recommender system that matches the right content with a user at the right time? Historically, we would use approaches that are not personalized that work pretty well for many kind of portals and big websites. You would use this approach called multi-arm bandit, where it's a form of reinforcement learning, but you're very kind of quickly looking at signals and updating what you're recommending. But it was hard to personalize using that approach, and there were ways to kind of create clusters or cohorts for personalization, but it wasn't true like at the user level. And one of the challenges had always been you had to go through this pretty rigorous approach to sort of feature engineering. Okay, what do we know about the user? Where do they come from? Have we seen them before? Have they clicked on something? Okay, how do we represent their interests by tags or keywords or topics? And it was never really great. I mean, I think that's where, when you had social networks and social media, you could use their social graph to understand what they may be interested in, right? So that was a pretty useful signal. But what we can do now with Embeddings is we can say, okay, well, new users, we don't know much about. We know the article you're on right now. We may know where you came from, so we could certainly use that information. But if we have any signal about a user, and usually we do, like they've seen our articles before, we could start to represent a user by using this math, by looking at the embeddings of the articles that they clicked on, or the articles they spent the most time on, or the articles they saved, right? Actions they took on articles. So you could start to use this vector representation of interests as a really convenient way to represent a user. And we've seen pretty meaningful improvements when we now make the matches between our content and a user that's represented using this approach.
Well, the other big sort of matching marketplace obviously is AdWords, right? That's the most efficient business machine probably ever built to this date. And now 4,000 engineers at Google are trying to figure out like what's AdWords, like where's that going? And what you're saying about embeddings tied to a user is actually really interesting, because media sites historically have not been the best monetizers because you didn't have the intent of the user. But now that intent went away for Google as well. And effectively understanding the user, having those kind of embeddings about the user, describing what's of interest for them, is a new form of a matching engine potentially. So how does that change for media sites? The core business notion of intent versus finding the right ad units for the right user.
Yeah, I think the difference for media sites now is you could do a lot more with less signal. And so we can use, I would say historically, media sites would not be well positioned to have like captured a lot of information, unless we're talking about loyal users who logged in and came back frequently. So there may have been, viewers who came for a handful of articles. There wasn't enough signal to truly, tailor campaigns and target campaigns of these users. I think you could do a lot more with less signal now. A user, and then sort of identify adjacent campaigns and include users in targeting for those campaigns. I would say, the biggest problem for media companies is just the size, and it's very hard. Even a large digital media company, it's very hard to compete with the scale of a platform, right? Like Google or Amazon or Meta, who have sort of endless inventory. But I would say I think it's easier to target now. This stuff is much more accessible. You don't need like a massive 4,000 engineers, right? You could do this with a much smaller team and with a few sort of existing capabilities. So I do think the advances that we're seeing is giving smaller players the ability to, own much more of the stack, especially in the advertising space.
It actually, you can imagine a world where the database about a user, describing the user, be it embeddings, be it something else, is actually distributed, right? It's not like centralized. Google obviously has the signal, which is, hey, you search for that. But for that matter, Meta has always historically had the database about people. So you could actually see different media companies collaborating because it's kind of a normalizer, right? Embeddings are embeddings are embeddings. The user is interested. So I can actually collect more information of what's of interest for a specific user and what's and multiple users. So this can probably change the ad tech stack in more than one way.
Yeah, and I think all the third-party providers and the advertising world has been changing pretty dramatically, especially since kind of Apple added all the all the changes to its mobile platform, right? Although Chrome was about to launch these changes, and then they kind of took a step back. But historically, we didn't use much, historical data about users. You just needed to know that a cookie, of a page view is associated with a cookie that you've seen, that you have an email, and you can kind of cobble together a view of a user across websites. So you had all these third-party players be really critical to creating kind of targeting for ad campaigns. And I think there's a lot more that could be done within websites now, but also if publishers kind of band together.
Yeah, it's a sort of invisible IP mode of who the user is, what they're interested with.
And it's especially important now. I think if you talk to any publisher, anyone who works in media, like everyone's talking about direct traffic. And so we're in a world where there's less and less passing of users from one website to another. And the publishers and media companies that will survive this period are the ones that have a brand that people know and go directly to.
Yeah, it's far. I totally agree. That's really interesting. It's less of a PPI. So you also have a PII, less PII issue because effectively you're just describing people with 1,536 vectors, right, of just scalar space. So it's not that you know anything unique about them other than what they're interested with.
Yeah, as a vector.
Yeah.
I know your vector.
Yeah. If I look at costs and gotchas, right, it's like we make it seem as if that's it's an obvious thing and everyone should do this. But if you look at the early days, cloud used to be about 10% of company cost structure. So your cloud costs, and I now see companies with LLMs taking about 30% of their budget of the cost of service. So that's usually expensive.
Are they training though? Are they building their own models?
No, inference. Actual inference. If you just take advantage of a standard model, and that's why distillation is important for companies that are scaling on the LLM side. But actually, embeddings. If you look at kind of cost structure of embeddings, like what's the big gotchas that if you could travel back in a year, that you would advise yourself to take notice of?
Embeddings are actually not. I think the vector database, the vector store, if you're using a hosted vector database, that is probably the most expensive piece. The embeddings themselves are very much available and very, very efficient and, not cost prohibitive. So you can, as long as you have static content, which we do for the most part, we publish a piece of content, it doesn't change. If it does, it's not that often. So we don't have to regenerate an embedding. So for our content, it's very inexpensive. I think it's different for a user at the user scale. And that's where this area is a lot more experimental, where we're creating an embedding for every user. Obviously, if we updated every few minutes, that would be pretty expensive, prohibitively expensive. But if we don't need to update it, or if there are ways for us to kind of update embeddings without these inference calls, if we update it daily, I think the costs. The cost is manageable. The place where we are saying the highest cost is obviously the rich media, so the generative media, image, video, like inference and models, and that's obviously a different topic. But that's hurting a lot. But on the text side, it feels very accessible.
But with the multimodal, I wonder, like with the multimodal models that are coming out, many of them don't yet have embedding generation. So I assume if like one workaround would be, hey, let's look at this image, let's generate textual representation, then use embeddings. Have you experimented yet, or are you excited with some of the multimodal stuff that is coming up?
Yeah, we haven't found a great use case for it just yet, although I think obviously embedding images along with text could be really valuable. We've just found that the text that we have is enough, and all the metadata that we have is sufficient, and we get really great results with just embedding the text. So we haven't yet included the images themselves as part of kind of the representation of a piece of content. But I could see it coming. I could see it, there could be a future use case where it is valuable. I think there's also a question of how, as this capability becomes more, integrated into more product surfaces, like what do we embed? We embed the article, we embed the author information, we embed maybe updates, we embed adjacent stuff. And so you could start to get to a point where, you have multiple embeddings for every article and also multiple embeddings for every user. They represent different aspects of a user. Like one may be clicks, another may be likes, another may be social things their friends like. So different features that then are used in recommender systems. So that can scale exponentially, especially as this capability gets integrated into our stack.
That's super interesting. Like clustering, finding the different facets about a person. So having a well-rounded person, just according to the number of embeddings and kind of the distance between the embeddings that represent that same user, it means the bigger the distance, it means they're interested with more things or different topics, or which is pretty like what's your diameter of interest, right? One could think of. I love that.
Yeah, one thing we found is actually we have to be really careful when we average out your interest. So if we take, for example, we take a user's clicks and we average them out, there are instances where the average is actually meaningless. It doesn't tell us much because if you think of all these different points, the average is in the middle. And so what we've actually found is by clustering our articles and our topic space. So we take all the content that we publish, we create clusters, and then we effectively relay users to these clusters. And we have a better sense of kind of the interests a user has rather than just simply the math, simply averaging into the middle. And so the clusters play a really critical role, and it's become one of our dominant features in all our classification models, our predictive models, and our recommender systems.
What's the quickest win, right? If I don't think of like RAG systems that just generally use embeddings in order to find text that might be relevant to push into the context, what's the quickest win maybe for one or two types of companies?
Yeah, so any content company, recommender systems. We saw a double-digit improvement in click-through rate. So that's very clear. I think the other piece is retrieval. So I'm not thinking RAG, but just effectively internal search, or different ways to kind of comb through your items or your corpus of items as a company. It could be Slack messages. It could be customer service, text. I think it could be a range of things, but as long as it includes, text that has semantic meaning, you could really query pretty in a flexible way and get related content.
This is awesome. That was my conversation with Gilad Lotan, head of AI, data science, and analytics at BuzzFeed. And I think it's clear that embeddings aren't just another buzzword. They're a new building block. Whether you're clustering content, clustering people, or rethinking how business models like ad tech might evolve, embeddings open up entirely new ways to create value. If this episode cut through some of the noise for you, share it with a friend or a colleague who's building in AI. And make sure to follow Almost Human so you don't miss what's coming next. I'm Shochat. Thanks for listening. We'll see you next time.